everyone. I'm Aqsa Taylor, Chief Security Evangelist at Exaforce, and you're watching an episode of It's SOC AZ podcast, where we break down attack campaigns, technical implications of it, and how to use AI or other ways to protect yourself against them. On today's episode, I have Joe Odyn with me, and he was actively watching the attack campaigns happening and also proactively looking for these threats in our customers' environment. And I'll hand it over to Joe to introduce himself and just jump into the topic.
Hi, Aqsa, and thank you for having me, everyone. My name is Joe Odyn. I am lead detection engineer at Exaforce. I come from military background, and then I switched to cybersecurity, where I was working as security analyst at a security startup in Boston called ThreatStack. And I evolved, it was a standard classical SOC. Then I transitioned to working as an SRE. From there, I moved back to Exaforce as a detection engineer, where my work is mainly focused on detection, on threat hunting, detection response, fine-tuning our detection, and leveraging the AI tools of the AI platform we have at hand to make sure that we're keeping all the environments as safe as possible.
Nice, nice. So, Joe, you recently wrote about the Team PCP attack campaign and as an MDR, how you went about the whole investigation process. But before we dive into that case study, can you tell us a little bit about how MDR itself has evolved now that you are an MDR with an AI SOC platform versus before AI SOC platform? What are the major changes that you have seen in your day-to-day life?
That's a really important and very big question, honestly. Like to compare the two, talking from my experience from a standard classical SOC from my previous job, everything is, the word that comes to mind is static. Everything is very rigid, very not so customizable. You have a SOC, you have a bunch of guys or a bunch of engineers or analysts working in that SOC, and you feed them X amount of data sources. You feed them, like, if you want to investigate something, you have to look into your SIEM and you have to create custom functions, custom queries to go search for something. And then you have to correlate that data across an additional data source somewhere else, and so on and so on. And therefore, once you have a traditional way of, once you have some kind of a threat hunt or something you want to investigate across, you get some threat feed. You start by assigning one X amount of individuals to gather all the IOCs, figure out where you can actually extract, like if you have an IOC and, okay, what is the data source that I can look into that can help me get this information, and so on and so on. And then that takes quite a bit of time. Once you have that, you will initiate your investigation, either using your SIEM, for example, or in some cases, let's say the platform where my previous job, they use Jupyter notebooks and so on and so on. And therefore you start the investigation, you start gathering all kind of data from X, Y, and Z log sources and data sources. And that was a very tedious process. That was very rigorous process. And especially if there are new IOCs that are coming out, it's very static. It's very not so flexible, and it doesn't really evolve with the current threats that we're facing. Whereas, and even your response was very like rigid, like it's very step by step. Okay, this thing happened. Let's follow this process, and very time consuming from the time you get a threat feed to some actionable information. That was hours and hours. So that is from a standard SOC approach. From an AI platform, from AI first platform like Exaforce, we take all these data sources and we combine them into a single platform. We don't just, and that's the thing, we don't just ingest logs or something. We take all these data sources. Our LM runs across all these, and they find actual correlations, patterns across all the things. Because if you're in a traditional SOC, when you're investigating something, it's very unlikely that you actually go look at that person's Slack events, for example, or that person's GWS event, and so on and so on, because there's a lot of information. It's too much for a single person or even a bunch of individuals to actually analyze and take a look at it. Mm-hmm. Second of all, so how the process goes on in a AI SOC platform is that you get a threat, you get some threat intel, the ability to extract the relevant IOCs, collect all the data, extract as much information as possible from the open sources online. Being able to categorize those IOCs in a way that actually find actionable IOCs, meaning you need to have knowledge of that environment and how your detections, what works for you, for example, because you're not just searching specific for logs. Nowadays, you're also searching for config changes. You're searching for specific behaviors, which is very hard to detect in a standard SOC.
Right.
Once you generate the IOCs based on very context-aware approach. and therefore you're you're able to know what can be actioned on and where to find that.
Hmm.
Once you do that, you generate detections that are able to look across for those IOCs across all your platform all at once. It can even have the reasoning to make conclusions like, hey, I'm searching for this specific IOCs, but then there's something else that's like slightly pivoting from this one. It has the logic and the context to pivot from it and even dive a little bit deeper into that. And then take everything and generate it into a human readable result that is something any executive or any person on the team can actually action on and understand what is going on.
Nice. That's definitely quite a change. Now, some may argue about automation, right? Hey, why can't you write automation scripts or playbooks for some of these response actions or even streaming, extracting data on IOCs and such? So, how is that different? And I'm sure there is a major difference between using an agentic solution or AI solution in a specific task, specific agent versus an automation script. But I would love to hear from you and your thoughts on this.
As I mentioned earlier, the word that comes to mind is very static. When you're writing an automation script that will, okay, I'm going to pull all these IOCs, but how would you codify what is relevant into that IOC? How would you codify, okay, if I'm telling, I want to have this team PCP, for example, and how do you tell it that, okay, scope it to this specific like, not just campaign, those specific, this compromise, scope it to this specific windows, and then search, and then figure, also add to it what is also relevant. And then at the same time, how do you scope into what is relevant to your detections, like your log sources, to what is actually in your infrastructure? So that's the hard part here. And then you did it for this specific IOC. So you're going to do it again for the next one. You can just keep writing new scripts, this is a very primitive approach. It's very static, very sort of legacy approach. When you use, for example, our task agents or use automation agents or LLM models to generate those IOCs, you just create the logic behind it. And it makes it much more reusable. It makes it much smarter. And at the same time, instead of you spending all that time on creating those scripts and customizing those scripts and so on, you're freeing your attention towards actually doing like the remediation, digging deeper or analyzing some results.
Yes, yes. Let's talk about Team Pacific case study now, which you've highlighted in your article. And you walk through it step by step. And one of the first steps you talk about when you're talking about the IOCs is that it's not one distinct static entity to check. It's a chain of things, and configuration is a huge part of it as well, which a lot of SOC platforms derive or drive more on alerts and events and hey, something happened, something risky. How does configuration play the role, and what has your experience been in this?
The Team PCP was a very interesting use case here because the IOCs itself, just like you mentioned, they span from compromised packages to specific file hashes. It expands to searching for specific C2 domains URLs that were used for C2 base, for example, looking at specific malicious file and depending on the operating system that you're working with, and it also affects how we're just talking about earlier, like how do you know if it's just not just something that goes into your GitHub workflows, for example, or packages,
Right.
but you also have to look at your developers. What is that person doing, and so on and so on. And the way it worked is that there were at some point somebody was able to compromise this repository and therefore was able to push compromised packages, that pre-existing packages across. And therefore, whenever you pull that package or you through a workflow or whatever that is happening, therefore, you're pulling some Trojan with it. And so, it started with a corrupt telnet file where Team PCP modified a .py file. And keep in mind, Team PCP are a North Korean group that are very active and very nefarious group of people. So they started by corrupting the telnet files and corrupting the client.py file. And therefore, the next step from that on was use how they delivered the payload. They hid the payload through WAV file using stenography. So basically, they embedded the payload through audio files, which helped it mask it from the detection part. It was like it's already too late by the time we figured it out. Once it did that, and again, the article will dive a little bit deeper into the technical details. So that's why I'm being high level here in my explanation. Once the malware made its way into your environment, the credential harvesting starts, and that thing targeted private key, SSH private keys, AWS GCP configurations, Kubernetes configurations, and so on and so on. And finally, there comes the exfil stage where they pushed all this stuff to those C2 domains that we highlighted earlier. And additionally, it had the persistence stage where the malware itself, especially on Windows, it worked on creating persistence for later compromise and later use.
Now, where or which parts of this did you use agents for, and how did that impact your overall timeline, your operationalization or efficiency?
To be fair, AI was involved and our agents were involved from the beginning. From them, like there, I don't see a single step that did not involve agents, which is great. And it's easier to explain it by explaining how what took place, how I reacted to it. So the flow is that we got a threat intel, we got threat feed through our channels.
Hmm.
Immediately, we utilize one of the agents to extract and build the proper IOCs for that one and expand the IOCs. And even as it was still building the IOCs, we just ran it a couple of times because it allowed us to update the IOCs because the IOCs were coming in really, really fast. So once we created the full list of IOCs, and the list of IOC was very, very big. Once we created the IOCs, there was a second automation agent that actually went ahead and created all the detections for this one. And that's what I said earlier. It's very hard to understand your environment, how to detect and what to use to detect what.
Right.
Therefore, we used AI, basically gave it already created the logic and the prompts for it to understand what are the tools available at our disposal, what's the tools at your disposal, the logic, how you want to go ahead and actually dive deeper, how to actually make sense out of the results that you're doing, and so on and so on, build a correlation and so on. So that agent created all the relevant prompts and the detections, which created engine and which resulted in an automation agent that is deployed across customer environments. And that automation agent did all the threat hunting. That single automation agent replaced an entire SOC, and it's digging deeper. They can look at all the results, and at the end of it, wrapped everything in a very nicely looking PDF and send it via email. Then instead of us focusing on creating all of this, we just mainly I focused on analyzing the results. And even when analyzing the results, we can even we provide those reports and actually pivot from that one. We're actually asking the automation agent or the LLM to create more customizable based on these results so we can dive deeper into those results.
That's great. And it essentially highlights the fact that AI is not here to replace the analyst role. It's here to elevate your role to a judgment zone. So now you can focus on making those judgment calls and really focus on containing or responding to the threats than focusing on the cumbersome tasks that the agent can handle for you. And of course, it also depends on what kind of agent you're using and if you can sufficiently rely on it, because if the agent's not pulling the right data, like the configuration data, the identity data, the mapping, and all of this, then you're going to have incomplete results. And if you can't rely on incomplete results, especially at a high stakes moment like this. So thank you very much for highlighting that. And for those who are watching this, please go read his article where he breaks this down in detail. Maybe before we wrap up, I have one last question for you, Joe. What would you tell MDR teams to not do? So you talked about how you did it and what you did, but are there any pitfalls to avoid in your opinion?
Do not dismiss AI. AI is not here to replace anybody. It's literally just augmenting the work. I myself did the work of an entire SOC. We have customers who utilize our platform, utilize AI, and therefore a single person is replacing a SOC team that's usually in traditional company should be 20 to 25 people. And this is all replaced by a single individual or with automation agents. So that freed up the individuals to do more relevant work.
Awesome. Thank you very much, Joe, and thank you for the viewers who are watching this. Stay tuned for the next episode.